Hello, so far I've gone over logarithmic equations with you and exponential equations. Today we're going to put those together and maybe see a few new types of problems as we solve some equations. So I want you to take a look at this black screen right here while I turn on the camera that faces the document. There it is, exponential and logarithmic equations. That's what we're going to be talking about today, and these are the problems we'll be going through. So if you want to, if you don't have a copy of this printed, you can pause the video and write down some of these problems. Give them a try. That's 1 through 10, and we're going to go all the way through 18 there, okay? Those are the problems, and once again, just like the other videos, I've taken that and wrote everything out larger so you can see it a little bit easier as we do them. Number 1, we start with an exponential. 3 to the 4 minus x minus 7 equals 74. On all of these, I just want to get x by itself. So as far as my class goes, once you get x by itself, you're done. Let's take you through that one. So to get the exponential by itself, first I'm going to add 7 to both sides. And this gives me 3 to the 4 minus x is equal to, what do we got here, 81. And now I need to get the 4 minus x by itself. Here's a case, when we did logarithmic equations, sometimes we switch those logarithms to exponential functions. In this one, I'm going to switch it back to a log function. So this is base 3. I'm going to change it to log base 3. So I'm converting exponential form here into logarithmic form. Log base 3 of 81 equals my exponent, because a logarithm is an exponent, 4 minus x. And now I can say, okay, first, do I have, this is a case where maybe 3 raised to something does equal 81, so I could probably substitute that out. Let's see if that is the case here. So if I have 81, what does that break down into? 9 times 9. And 9 breaks up into 3 times 3 and 3 times 3. So 3 to the 4th power equals 81. So if I'm talking about a logarithm, if I say log base 3 of 81, what does that equal? What it's saying, what do I raise 3 to get 81? Well, I raise it to the 4th power. That's what I just saw right there. So you could say in this case, this right here equals 4. See, log base 3 of 81 equals 4. So you get 4 is equal to 4 minus x. I'm going to subtract 4 from both sides, and when I do, I get 0, right? 4 minus 4 is 0. I'm going to continue on up here because I wrote the next problem down below. 4 minus 4 is 0, so you get 0 equals negative x, or x is equal to 0. And we can go back and check this. If we have 0 in right here, we get 3 to the 4th, which is 81. Sorry, 3 to the 3 minus, let me start over here. 4 minus 0 here, which is 3 to the 4th, right? And that equals 81. And 81 minus 7 is 74, so it all checks out. All right? Sorry about that. That was number 1, though. Let's take a look at number 2. So number 2, we've got 2 to the x equals 11. So once again, I'm going to convert this to logarithmic form. And so I have log base 2 of 11 equals my exponent, because a logarithm is an exponent, right? X is by itself here. So I'm happy with that. That's what I mean by this right here. Sometimes we can look at it and say, hey, I bet I can convert that to a number. In this case, 2 raised to some x power isn't going to give me 11 perfect. You can punch this in your calculator and get a decimal form, but for my class, talk to your math teacher, see if they got something different going on. As long as you get x by itself, I'm not going to make you try to put that in the calculator and figure it out. So we stop there because x is solved for. Number 3. Number 3 is e to the x equals 44. We want to get e by itself. Let's put it in logarithmic form. What is log base e? Do we write out log e? No, we don't write out log e. That sounds weird, doesn't it? We say natural log like a mathematician would. So that is the same thing. By the way, if it helps you, you can write out log base e. Just like we did up here, we said, okay, log base 2. And then say of 44 is equal to x. I don't want you to leave your answer like this because we want to write like mathematicians. But if it helps you think about it, you want to put a number down there as the base, write log base e of 44 equals x, and then know that we need to change this to natural log. So we're going to write it with natural log of 44. That's the same thing as log base e of 44 is equal to x. You can punch this in your calculator pretty easily and say natural log of 44, get a decimal, but I want the exact value. I want you to leave it just like that. X is solved for, so we are done with number 3. Let's take a look at number 4. See my artwork showing up as it's just my page. That's just a sacrificial page because these Sharpies bleed through everything I write on. But it is very abstract. The natural log of x minus 1 is equal to 2. So once again, this is now in logarithmic form, but I'm going to put it in exponential form, okay? The natural log has a base of what? We just talked about number 3 has a base of e. So it's like, if it helps you, once again, you write it out as log base e of x minus 1. Just don't let me see that in your answer. So you say, okay, it's got base e. So if I'm converting it to exponential form, I'm going to say e is the base, and it's raised to the exponent of 2. And it must equal the input of my logarithm, or x minus 1. So this is just converting it from log form to exponential form. And then to get x by itself, I'm going to add 1 to both sides. So I get e squared plus 1 is equal to x. And notice if I plug that back into my equation up there, I would not get a negative number because 1 minus 1 is 0. Can't leave it at 0, but I'm adding also e squared to it, which is going to be positive. So it's okay for x to equal e squared plus 1. That's my answer. Just try to box in your answers as we go along. Now this one, we did this in one of our videos where we had a ton of these types of problems, and we're going to go back to our properties of logarithms, right? And on our properties of logarithms, we said that if we have log of a plus log of b, it equals log of a times b. Doesn't matter the base, but in both cases we have common logarithm. Actually, the base does matter. Both of these have to have the same base, but this could be log base 3 and log base 3, log base 4 and log base 4. In this case, it's log base 10 and log base 10. That means when I combine them, it's going to be log base 10 of x times x plus 9. And if I distribute that x, I get x squared plus 9x equals 1. And here's a case, I don't have a log on the right side. Now we did a bunch in the other video where we had log base 10 of this mess equals log base 10 of this mess. In this case, I don't have that. So I'm going to convert it now to exponential form. This is log base 10. So I'm saying, okay, my base is 10. Here's the exponent 1, and it must equal what's inside the parentheses, x squared plus 9x. 10 to the first, same thing as 10 here. It is a quadratic, so I'm going to move everything over to that side right there and then solve by factoring. So I get 0 equals x squared plus 9x minus 10 because I subtract 10 from both sides. And I want factors of negative 10 that add up to the middle term 9. That's going to be positive 10 and negative 1. Multiply to give me negative 10, add to give me 9. And look, whoever created this problem is nice because the leading coefficient is 1. Which means I can say this is x plus 10 times x minus 1. And so you get x equals negative 10 and x equals positive 1. Remember in that last video, if you haven't watched it on logarithmic equations, go back and watch it, all right? I worked hard making that thing, so I want you to not only work hard, but also understand this because we go in greater detail with this. Anytime we get a logarithm, it has to be positive. That we're taking the logarithm of. It can't be 0, it can't be negative. So I need to make sure when I get these solutions, no matter how good I feel about it, no matter how on point I feel doing my math work, that I go back and plug them in and make sure I'm not taking the log of 0 and make sure I'm not taking the log of a negative number. In this case, negative 10, that is a negative 10 just bled together there. Negative 10 goes in, I get log of negative 10. So that's not going to work there. That one's out. You put 1 in, you get log of 1. That's okay. You get log of 10 right there. That's going to be okay too. So x equals 1 is my solution there. All right. Next, number 6 here. Once again, we're going to do the same steps. We're going to say, okay, we got log base 10, multiply what's on the inside here. You get x squared minus 9x, and we are taking the log of that. That equals 1. Here we're going to convert it to exponential form because it's not log equals log, it's log equals a number. So this is base 10, so I'm going to raise 10 to this power, 1, and set it equal to x squared minus 9x. Wait a minute, is this the same problem? No, there's a minus there, there's a plus sign there. I was like, wait a minute. So we get minus 9x, the last one we had plus 9x, right? Let's see how that changes things. So if I subtract 10 from both sides, I get 0 equals x squared minus 9x minus 10. And I want factors of negative 10 that add up to negative 9. In this case, it's going to be positive 1 and negative 10. Multiply to give me negative 10, add to give me negative 9. And so because the leading coefficient is 1, I'm going to say this is x plus 1 times x minus 10. And so x equals negative 1 and x equals positive 10. And so as I go to plug this one back in, what do we got here? We got positive 10 going in, and positive 10 minus 9, that works, and positive 10 there works, so that one's good. So that's a solution. Let's try negative 1. Negative 1 minus 9, or log of negative 1, both of those are out. So the negative 1 gets thrown out this time, but the positive 10 is good for an answer. Positive 10 there then. All right, on this one, number 7, same thing, but be careful here. We have a minus sign this time, not a plus sign. Let's go back and look at the rule on that. Before we've been having plus signs, so we say a times b. If you have a minus sign, this first one gets thrown over the inside of the second one there. So it's going to be a over b. So pay attention. Don't accidentally say we've been doing plus, plus, plus. We've got a minus here. So this is going to be the natural log. That's a really bad pen for the video, so I'm going to throw that one to the side. Let's go back to the other color. The natural log of x plus 3 divided by x is equal to 1. Remember, we can't cancel out the x's because both terms right here do not have an x. You know, if we had x plus 3x, we could cancel out some x's here. Can't do that in this case. I'm going to convert this to exponential form. Remember, this is the same thing as log base e, so the e is my base for the exponential form. This is my exponent, 1, and it must equal x plus 3 over x here. So if I get rid of this x, I can move the x over, and you get x times e to the first equals x plus 3. And then I say, okay, I'm going to move this x over, and so I've got x e to the first minus x equals 3. And notice what I can do right here. I can factor out an x. So I'm going to continue this problem up here. If I factor out an x, I get x times e to the first minus 1, and that equals 3. And then divide both sides by e to the first minus 1. So I'm dividing everything by e to the first minus 1. That cancels that out, and I got to do it to this side as well. And so I end up getting x equals 3 over e to the first minus 1. That's my answer right there. Okay, x is by itself. I know it looks weird, but remember, this is a number. Minus 1. It's 2.71 minus 1, and 3 is up top. And that's all we're going to do with that one. All right. Next one, number 8. Once again, we get that minus sign there, so I'm going to say the common logarithm log base 10 there of x plus 4 over x is equal to 2. And I'm going to say, all right, base here is 10, so I'm going to say 10 raised to the second power is equal to x plus 4 over x. I'm going to kind of work this the same way, but I know 10 squared, it's 100. So if I multiply both sides by x, I get 100x equals x plus 4. Just in case that was too quick for you, I multiplied 10 by itself. 10 times 10 is 100. And then I multiplied both sides by x. Sometimes I don't want to skip steps, and then some people are trying to fumble around and figure out where I went with it. Subtract 4, or not subtract 4, let's move those x's over. Subtract x from both sides. And so minus x and minus x, I get 99, not problems, but 99x's, right? Equals 4. divide both sides by 99, and I get x equals 99 over 4. You know what I forgot to do in the past couple ones here? I know that 99 over 4 is really close to 25 because 100 over 4 is 25. So make sure that if you're to put 24 or 25 in here, it would not give me a negative or 0. It doesn't in that case right there, so I'm good. All right. Likewise, up here, we want to make sure that when I substituted that back in, I didn't get a negative or 0. I already knew it didn't, but it is good practice to go back and check. So you say, Mr. Burnett, how do I know? I don't even know how to work that. How do I put it in here and make sure I don't get a negative or a 0? Well, just think about it. This is about 2.71, E is. E is approximately 2.71, and E is the same thing as e to the first. So if I subtract 1 from it, I'm going to get 1.71. And if I put, I'm saying 3 divided by that number, 3 over 1.71 is going to be somewhere like 1.5 or something. It's close to 3 divided by 2. If I put that in here, is that going to keep that positive? It is. If I put it in right here, it's already a positive number. 3 divided by 1.71 is positive. So it's not going to be 0. It's not going to be negative. And I'm not going to give you something that's going to be questionable there. It's going to be, if you use that logic, it's going to work. All right. You could also punch it in the calculator and check because you are allowed to use non-graphing calculators in this class. So I guess you could check it that way. But I'd like for you to build number sense as we move through these. All right, number 9. Let's straighten this up and do number 9. I've got the natural log of that mess equals 0. Once again, I'm going to convert this to an exponential form. So this is base e. So I have e raised to this power right here, which is 0, must equal 3x squared plus 2x minus 4. Well, e to the 0, anything raised to the 0 power is 1, even e. E is just 2.71 something. So I'm raising this to the 0. That's going to be 1. And then I'm going to subtract 1 from both sides. So I get 3x squared plus 2x minus 5 equals 0. And I'm working towards factoring this. So this one's a little bit more fun to factor. I'm going to say 3 times a negative 5 is negative 15. And I want factors of negative 15 that add up to 2. I'm thinking 3 and 5 here, with the 3 being negative. I cannot take the shortcut because the leading coefficient is not 1. So I'm going to break that 2x up into negative 3x and 5x. And I'm going to factor by grouping. So I'm going to group these two together and group these two together. Factoring out a 3x here, I end up with x minus 1. Factoring out a 5 here, I get x minus 1. That's what I like to see, those two things to match up. I'm now going to factor out an x minus 1. And that's going to give me x minus 1 times 3x plus 5. And remember, all of this equals 0, right? I just made this into this right here. It still equals 0, so I'm going to set each term equal to 0. So x minus 1 equals 0, and 3x plus 5 equals 0. I have to draw a line here so we don't get this mixed up. I wrote this next problem up too close to it. So add 1 to both sides, you get x equals 1. Subtract 5, you get 3x equals negative 5. Divide by 3, you get x equals negative 5/3. What do we need to do? We need to go back in and make sure that's not negative and it doesn't equal 0. Well, a couple of things that we can do to make sure that doesn't happen. Let's see. Well, no, see, that became a 1, so that's going to be different. This factored form is different than this form. So let's go back and look. If I put 1 in, 1 squared is 1, so I end up with 3 plus 2 minus 4, which is positive. So that's going to work. X equals 1 is a good solution. This could work also, though, so let's try this one out. If I put it in, let's grab a scrap sheet of paper here so I can have a little room to do this work. Negative 5/3, that's what we need to put into 3 negative 5/3 squared plus 2 times negative 5/3 minus 4. So this becomes negative 10 over 3 minus 4. And this squared gives me 25 over 9. And then we're going to times that by 3, which is 75 over 9. I'm going to go ahead and put this into ninths. I'm going to get minus 30 over 9. put this into ninths, and I've got 36 over 9. And so this gives me negative 66, and that's less than 75. Or if you're subtracting it, you would actually get 9 over 9, which equals 1. So that works. It's a positive number. It's not 0. So both of these are acceptable solutions for number 9. All right, number 10. Once again, we're going to use those properties of logarithms. This time we got a plus symbol. So we're going to say the log base 10 of 3x. That equals the log base 10 of x plus 3. Since the bases are the same, I can set what's inside equal to each other. So x plus 3 equals 3x. Subtract x from both sides, and I get 3 equals 2x. Divide both sides by 2, and I get 3 halves is equal to x, or 1.5. Now I need to go back in and make sure that I get non-zero and non-negative numbers when I put 1.5 back in. I do. So that one works. It's always funny. Sometimes we do these really difficult ones, and then all of a sudden in a set of problems we get an easier one. It almost throws us off, like that was a little too easy. What's going on here? But nope, that is our answer for number 10. Number 11 coming up at you. All right, so this is what we have. We have the negative log of x minus 2 equals 1 minus log of x squared minus 4. So I want you to think about your properties of logarithms when you see something like this. When we're looking at these properties of logarithms, you can say the log of a plus log of b, log a minus log of b. We have properties that go with that. We even have properties where we say b times log of a. You can move this b up in the exponent form and get log ab, or move it the other way. If you got that exponent, you can move it out front and say b times the log of a. But we don't have anything right here where you just got b plus or b minus. So if we're going to move that b up and make it an exponent on something like this, it had better be a time symbol in between those two things. If I'm looking right here, this 1 is not saying 1 times, it's saying 1 minus. So we can't move that 1 up top or anything like that. Same thing here. I mean, right here you could move the negative 1 up, but let me show you how I would solve this, because I think it's easier than moving this and making it negative 1 as an exponent here. I'm going to add the logarithm to both sides. So I'm going to move all the logarithms to one side of the equation, and as you get experience with these, you start to get into a rhythm of what to do. So if I add log of x squared minus 4 to both sides, this all is going to cancel over here, and I'm left with just 1 on the right side. On the left side, I can't combine these two. I'm just going to write it out like this. The log of x squared minus 4, that's this first one, minus, because it's got a negative there, the log of x minus 2. And now look what I've got. Now I can use one of those properties, right? Let's pull that back down here. If you have the same base, you can say log a minus log b equals the log of a over b. And that's what I'm going to do with this. I've got the same base, base 10. And I'm going to take the first one listed here, and I'm going to say x squared minus 4, and I'm going to put it over x minus 2. And I'm taking the log of that. That equals 1. Now we're at a point where we can actually put this in exponential form. I know it's log base 10, it's just not written there, that's log base 10. So I'm going to say 10 raised to the first power is equal to this mess right here inside the logarithm, x squared minus 4 over x minus 2. Now, could you factor this over here and cancel out something? You could, but that can sometimes lead to some mistakes. So I recommend not factoring and canceling here. Go ahead and multiply both sides by x minus 2. And so you get x minus 2 times 10 equals x squared minus 4. And distributing the 10 here, I'm going to get 10x minus 20 equals x squared minus 4. I'm going to add 4. Notice I've got a quadratic going on. I'm going to go ahead and move everything over to the left side and combine everything I can. So adding 4 and subtracting x squared from both sides, I'm going to get negative x squared plus 10x minus 16 is equal to 0. And that's what I'm going to factor there. If you want, you can flip the signs and make this x squared minus 10x plus 16 equals 0. And so I want factors of 16 that are going to add up to the middle term, negative 10. Let's see, I've got 4 and 4, that doesn't work. I've got 2 and 8. Make them both negative, and we've got a winner here. So this becomes x minus 2 times x minus 8. That equals 0. So I get x equals 2 and x equals 8. So notice if we had canceled over here, I don't think we would have gotten the same answers. Maybe, but I don't think we do. Or it just leads you, I think it might lead to a few mistakes there that students avoid by doing it this way. So x equals 2, x equals 8. If I put those in, I shouldn't get any negative numbers here. Don't forget, you do all that work and you get excited and you're like, I'm done, got my answers there. Do not forget to plug it back in or you might end up with an issue. If I put 2 in right here into that, I get 2 minus 2, which is 0. And I can't take the log of 0. So I need to throw that out. You put that in on a test as an answer, I'm going to have to give you only half credit here because you only give me, a partially correct answer. If I put 8 in, I get 8 minus 2, which is 6. That's okay. If I put in 8 right here, 64 minus 4, that gives me a positive number. That's okay. Cannot be 0, cannot be negative. Our answer here is just x equals 8. All right? That was number 11. Let's take a look at number 12. Number 12 says the log base 4 of x equals negative 3/2. Let's write this in exponential form. So I get 4 raised to the negative 3/2 is equal to x. Look at that. X is solved for. I'm happy with that as your answer. Okay? Let's go to the next one here. The natural log of the square root of x equals 1. We can rewrite this if we want to as the natural log of x to the 1/2. If that makes you happy, you can do that. Or you can leave it square root of x. Actually, in this problem, let's leave it like that. This is base e, right? So I'm going to convert this to exponential form. It's e, that's the base, raised to that exponent equals the square root of x. That's why I left it like that, because I want to square this thing. So if I square both sides, I get e squared equals x, which is just e to the second power. That equals x there. I'm going to zoom out so you can see this a little bit better, and I'm not being cut off at the bottom there. And that all of a sudden got brighter, so let me dim this down. There we go. All right, next one. Let's look at number 14. Actually, before we look at number 14, I do want to make a mention here that we could probably work this out a little bit better. I think as I looked at my previously worked out stuff, I think it's a little bit, I'd be happy with that as an answer, but I think it's worth mentioning how else we could solve that right there. So we've got 4 to the negative 3 over 2. Remember, that is the same thing as saying 1 over 4 raised to the positive 3 over 2. All right? And so if I take this a little bit further, I could say, okay, that's the same thing as the square root of 1 over 4 cubed. And so 1 over 4 cubed is the same thing as 1, because that's 1 cubed. And then 4 cubed is 64. And I'm taking the square root of that. So if I square root the top and bottom there, you get 1/8. So this does simplify to something a little bit prettier. Sometimes they're really nasty when you get like that and they don't work out. But I just thought it was worth noting when I check my answer key as I go through this that that's the answer. Number 14. So number 14 here, we've got the log of x squared minus 1 equals 1 plus log x minus 1. Once again, we get that plus symbol there, and that's not a logarithm. So there's no property of logarithms that help me out with this. So I'm going to subtract log of x minus 1 from both sides. That gives me the log of x squared minus 1 minus the log of x minus 1 equals 1. This is log base 10, so I'm going to say the log of x squared minus 1 over x minus 1 equals 1. Once again, we're going to convert this to exponential form. The base is 10 here, so this is 10 to the first equals x squared minus 1 over x minus 1. Multiply both sides by x minus 1. You get 10x minus 10 equals x squared minus 1. Subtract 10x from both sides. You get x squared minus 10x. Add 10 to both sides, you get positive 9 there. This all equals 0. And so I'm going to factor this one out here. So I want factors of, well, that, I don't know why I even tried yellow. Factors of 9 that adds up to the middle term, negative 10. I got negative 1 and negative 9. Multiply to give you positive 9, add to give you negative 10. The leading coefficient is 1, so when I factor this, it gets x minus 1, x minus 9. So x equals 1 and x equals 9 are my possible solutions. Don't forget, go back and check it out. 1 minus 1 right there is 0. So that throws out that one. Put in a 9. 9 minus 1, that's okay. 81 minus 1, that's okay. X equals 9 is my solution here. Okay? Always go back and check. Hopefully, if you've done all these problems with me, you're sick of me saying that, and you will never, ever forget to go back and check. Number 15. So number 15, I'm saying, okay, I've got log base 2 of 2 minus 2x plus log base 2 of 1 minus x equals 5. Here's one where I've got a plus sign in between bases that are the same. I can use that property of logarithms and say the log base 2 of 2 minus 2x times 1 minus x equals 5. I'm going to FOIL this thing out. 2 times 1 is 2. 2 times negative x is negative 2x. Negative 2x times 1 is negative 2x. Negative 2x times negative x is a positive 2x squared. And this is still taking the log base 2 of all that mess, and it equals 5. Don't just set it equal to 5. Because both sides are not logarithms, I can't just set that equal to 5. But I can use my properties of logarithms here to combine some stuff, and I'm going to continue combining it, put it in descending order, make it look all nice and pretty like we like to see. The 2x squared goes up front, minus 2x and minus 2x becomes minus 4x, and then the plus 2 goes right there. So I'm taking the log base 2 of all that mess, and that equals 5. Now I'm going to convert it to exponential form. So 2 raised to the 5 is equal to this mess. And 2 to the 5th, I can actually multiply that out. That's 2 times 2 times 2 times 2 times 2, right? So this is 4, and that's just 2. So it's 16 times 2, or 32. Right? So 32 equals all of that. It's a quadratic. I'm going to move that over. So 32, subtract it from both sides, gives me 0 equals 2x squared minus 4x minus 30. To make life a little easy, I see a common factor of 2 here, so I'm going to divide both sides by 2, and I get x squared minus 2x minus 15. And now I need to factor this. So factors of negative 15 that add up to the middle term, negative 2. I get 3 and 5. The 5 must be negative. Everything checks out. Leading coefficient is now 1. So I get x plus 3 times x minus 5 equals 0. So x equals negative 3, x equals positive 5. And don't forget to go back and check, right? So let's do that. Negative 3 goes in, and I get an issue right here automatically. 1, no, wait a minute, do I? Negative 3, I get 1 minus a negative 3, which becomes 1 plus 3, or 4. So that actually works. Oh, well, let's check and make sure it works everywhere, though. If negative 3 goes in right here, I get negative 2 times negative 3, which is a positive 6, and 2 plus 6 is 8. So yes, it most definitely works. Now the 5, though, down here, not so helpful. 1 minus 5 is a negative 4. That already gets thrown out. So this right here, negative 3 is my solution. So here we are with number 16, and number 16 is saying the log base x of 9/4 is equal to negative 2/3. And for something like this, you say, okay, now base x, we haven't done that one yet. Don't fear that. Let's put it in exponential form. So if the base is x here, if we put it in exponential form, we're going to have x raised to this exponent, negative 2/3, is equal to whatever we put into the logarithm, which was 9/4. Now, let me make sure this is focused correctly. There we go. So with something like this, first thing I'm going to do, and this is where it's helpful with that other one I went back and said, let's rework this again and see how it could play out. If we make this a fraction, x over 1, that negative there means I can flip the fraction and make the exponent positive. So I end up with 1 over x raised to the power of positive 2 over 3. Now remember what raising to a fraction does. If you forget, what I like to do is go back and just do this. I think most students have it memorized at this point that raising it something to the 1/2, like x to the 1/2, is the same thing as square root of x. If you don't, get that down because we will see that a bunch. Now, when we write the square root bar, what we really should have right here is a 2. But we don't, because square root means the second root right there, right? And this is saying this 1 goes right here. And so this is how we go from like a radical form to an exponential form. We have the 1 goes into the numerator, and this second root goes in the denominator. And so if, we don't see something raised to the 2/3 that often. So when we do, and you want to write it to a radical form, go back and write this out to help you keep track with that. So if I had x to the 2/3 here, that is going to equal, we got a radical and x right here. Notice the 1 went in as the exponent, so this is going to be 2. And the 3 goes right here. We're taking the cubic root of x squared, okay? And if I write this over 1, or under 1, remember this 2/3 can be, you can kind of think of it as distributed. We can say that's the same thing as saying 1 to the 2/3 over x to the 2/3. And 1 to the 2/3 is, 1 squared cubic rooted, which is just 1. I'm just going to write it back into our problem over here as 1. And then this, we already did it right here, is the cubic root of x squared. And all this equals 9/4. There's a couple different ways you can do this. This is just the way I like to look at it. Now, if I multiply both sides by the cubic root of x squared, I get 1 equals 9/4 times the cubic root of x squared. That's just multiplying both sides here. Cubic root of x squared times cubic root of x squared. These cancel. You're left with 1 equals this right here. And then I can multiply both sides by the reciprocals to get rid of this 9/4 here. So if I multiply this side by 4/9, it cancels out that. But you also have to do it to this side. If you want to look at it as dividing by 9/4, that's fine. Remember, dividing by a fraction, same thing as keeping it, switching it, flipping it. So it's like multiplying by 4/9. So 4/9 equals the cubic root of x squared. Still trying to get x by itself, though. So how do we get rid of that cubic root? Well, you cube both sides, right? So if I cube this side, that cancels, and then I'm going to cube this side right here. Cubing the 4, I get 64, and then we need to cube 9, which is 9 times 81. That's not in my head right now, so 9 times 9 times 9 gives me 729. And that equals x squared. And then from there, I'm going to take the square root of both sides. I still feel like this camera is not focused. There we go. So square root both sides, I'm going to get this right here. So x equals, and remember we can square root each one of these. The square root of 64 is 8. And then if you still got it in your calculator, you say, what is the square root of 729? And I get 27 there. So x breaks down into 8 over 27. You don't have to check this because we're not taking the logarithm of it. It's just base. The base right here is 8 over 27. And we don't have the negative base. We haven't really talked about that in this class. So it's positive and life is good. Number 17, kind of a similar thing. We're going to take that variable is in the base. We're going to take and raise it to the second power. So the base x minus 1 squared, remember it's the whole thing squared here, is equal to what I put into the logarithm, 4x minus 4. And so in this case, we got an x down here and an x there, so we will have to check that one. But let's go ahead and solve this thing out. X minus 1 squared, I'm going to do my shortcut for binomial squared. Square the first term, square the last term, multiply the two and double it, and that equals 4x minus 4. Add 4 to both sides, I get a 5 there. Subtract 4 from both sides, I get a negative 6 there. and all that equals 0. Let's see if that factors. I want factors of 5 that add up to the middle term, -6. I've got 2 and 3. Nope. 1 and 5. 1 times 5 is 5, but it doesn't add. Let's see. Make them both negative. Leading coefficient is 1. It simplifies to this right here. So x equals 1 and x equals 5. Let's go back and check it. If I put a 1 in, I get 4 minus 4, which is 0. I can't take the log of 0. Get out of here, 1. If I put a 5 in, I get 20 minus 4, which is 16. That is good to go. So x equals 5 is our solution there. Let's take a look at number 18 now. If you're at this point in the video and you've watched it without really taking a break, you should stop and take a break right now, right? You're 40 minutes in. Probably longer if you've been pausing. But no, this is our last question, so don't go away. We've got the natural log of 5x plus 2 equals 7. Remember, this is log base e, so when I convert it to exponential form, it is base e raised to the 7th power, and that equals 5x plus 2. I want to get x by itself. So I'm going to subtract 2 from both sides, and I get e to the 7th minus 2 equals 5x. Divide both sides by 5, and I get e to the 7th minus 2 over 5 is equal to x. And then don't forget to go back and plug that in for x up here and make sure that it works. All right, so just do that in your head very quickly. I'm just kidding. I know you can't do that in your head. It's like, it's this 2.71 something to the 7th power minus 2 over 5. You're like, what are you doing? But think about it though. 2.7 to the 7th power is going to be bigger than 2, isn't it? Right? It's like almost like saying 3 to the 7th minus 2. So this is going to be a positive number divided by another positive number. X is a positive number here. And when I put a positive number in right here and times it by a positive and add 2 to it, I'm going to get a positive number. It's not going to be 0. It's not going to be negative. So in this case, I know it will work, and that's where our number sense comes into play. Just thinking about things. You don't actually have to get the value. We just need to make sure that we're not taking the log of 0 or a negative number. Okay? I hope that you went through all those with me, even if it wasn't in one sitting. Even I, if you notice when you're watching the video, I take pauses and breaks and take drinks of water because it's 42 minutes long. You know, that's a long time to do math. And hopefully it doesn't take you 42 minutes to do these 18 problems. It takes me a little longer because I'm trying to make sure I explain every question you might have as we go along here. But those are those 18 problems. If you got through those and got them all right, good for you. If you got some wrong, that's okay, so long as you know where you messed up. If you don't know where you messed up, talk to me. Show me your work. I'll be happy to help you out with that, okay? Thanks for watching, and I'll see you next time.